Hey, welcome back to the basement. Today we're gonna step back a little bit from Clipper. We're gonna do something fun, something I've been looking to get in, something I'm excited about, something a lot of people have asked about and I've kind of shied away from until now. I'm gonna look at the Chaoticlab Tap, which is a CNC aluminum tap that's specifically made not from the original STL files or step files for the Voron, but basically made to mimic that, but in the best way possible to do aluminum, which makes it a little bit more rigid, a little bit lighter, and a little bit thinner. So let's jump into the PDF that they have on their open source Git and take a look at what we're dealing with. All right, so Chaotic Labs has come out with this Voron tap. They have a build guide right here. We're not gonna open up right this second, gonna open up in a second though, but I wanna look at this real quick. They tell you not to take the slider off the guide rail simply because it's preloaded. Manual disassembly will lead to product damage. So basically they want you to be wary of that. If you are familiar with these types of parts and whatnot, and you are comfortable and confident that you can specifically do that task, of course you can clean out the unit and whatnot. We're gonna get into that in a second. We're gonna clean out and lube it up. It comes basically with shipping oil on it, so it doesn't rust or anything like that. But we're gonna do a little bit to basically finalize that before we get on the printer. I'm not gonna put it on the printer today. We're just gonna go over the part today. Anyway, so information here, great file, about 15 pages worth, talking about a bunch of stuff about this particular product. Again, Chaotic Lab, and I'll have a couple links down below where you can buy it, where you can get it. I'm also gonna throw a link in to their Discord. A lot of good stuff on the Discord. You know, take it with a grain of salt, just like any other Discord, but pretty neat item here. It's almost not, I'm almost not able to call it a tap. I mean, it is a tap, it's a CNC tap, but it has a way different design than the original. For better or worse, I don't know yet. I haven't used it. I've played with it a little bit. Admittedly, I did put it back in the box so we can kind of open box it, but it does seem a lot more rigid than the original. Yeah, so anyways, let's jump right into take a look at this. So it comes in a cute little box right there. And again, it's Chaotic Labs. It comes in a black or a red. So that red is like a Voron red, the black is a black. And it's a CNC Voron tap. A little picture of it there and a little number there. But pretty basic box. Not much to look at. Okay. And back to the overhead shot we go. Looking good? Good. So yeah, so first things first, I'll make note is that this unit comes with an XH 2.54 3-pin connector on it, which isn't what I have on my Stealth Burner 2 part. That actually has a JST on it, so I had to replace this with the one. I've already done that on the harness in here, so I kind of prepped that a little bit. But they do give you a nice little pinout, if I can get to here in the PDF. That tells you basically what your power, your ground, and your signal wire is. So basically you convert that over, pretty easy. Basic crimping skills and tools, you should be good to go. All right, so let's open this thing up. Open it up. You have two relatively nice stickers from the Chaotic Lab. It's a good name, by the way, right? One with the name and one with the logo only. So get that. And around top here, we have guide rail. This product is factory preloaded. Manually assembling it may lead to product damage. Okay, so let's go over what that means. Preloaded means basically the ball bearings are in there specifically with a specific load, meaning that the amount of friction between the actual linear rail and the sled that's on there are specifically loaded to a certain amount so that there is little, if any, play in there. That's what the preload is. Loading, on the other hand, is basically the weight that you put on that sled. So that's that. So this product circuit module is only compatible with 5 volts voltage. Other voltages may damage the product. So if you've modified your Voron or whatever your attachments to, so you have 5 volts up at your head, you should be fine. If you haven't, you got to make that modification. We'll talk about that in a second. In terms of why this requires 5 volts, it's a little bit different than your average. Again, it's a very much different design. Please tighten both pre-installed screws simultaneously when fixing this product to the MGN 12H slider to prevent any one screw from becoming stuck. So basically, because this is aluminum, it's very rigid, there's not much flex in it, and everything's machined to a relatively high level of precision. What they're looking to do is make sure that you don't cockeye something on there so it lays flat as you're putting it down. So basically, you know, get your first screw in there, almost not snug, but just snug, and then start your other one and then tighten them back and forth a little bit until you get nice and snug, which is good even if you're working with plastic parts, but definitely more important when you're dealing with something so rigid. So part in the box, here we go. This is the Chaoticlab Tap. So I'm gonna set the rest of this aside for a moment. And what we're looking at here, and I'm gonna switch camera views so you can see a little closer. What we're looking at here is the tap. It is a lot thinner than your average tap, and it's pretty nice. Machining is very nice on it. The coating is very nice on it. So everything looks good. The mechanism seems to be nice, and the slop on this, if there is any, is not noticeable with my hands, and definitely not noticeable with my eyes. So they have that, which is very, very interesting because MGN 7 rails aren't known for being tight. Usually there is a relatively high amount of slop in those. That's why most spreads you'll see 9 or 12s. You don't see a lot of 7s, and that's part of that reason. But yeah, they've done a good job with that. So looking at the parts here, we have our front plate that the stealth burner would be mounting to. We have our clipping mechanisms here for our belting, which is a little bit different than what you'd find normally on a tap. These are basically metal plates that are screwed into the back plane right there, and a machine piece going into that on both sides. So you have your 2 belts on that side, your 2 belts on the other side, okay? And then you have MGN 7 here on the inside of this, on this rail. See, it's pretty small. And then you also have a specific optical switch here. Now this optical switch looks like a mechanical switch, and what it is a, it does make a little clicky there for the return on that, is actually breaking an optical path on the inside of here, even though it's using a mechanical way of doing that. Anyway, you switch it, it's mechanical, but this actually has a return on the switch itself, a spring-loaded switch, if you will, that basically returns it. It allows them to save space on this unit, save design, and it's actually a very nice switch from what I can see. So they've designed their own board here. On the top, we have a ZH type connector. So very, very small connector there. Save space again, weight as well. While we're talking about weight, space, and the part itself, go ahead and mention that this is substantially lighter than the actual tap that you build yourself. And the primary reason, I scratched my head when I heard that. I was like, well, how is it lighter than the tap? And you know, you probably know by now because I've told you that this is using the MGN 7, but that is the primary way they've gone ahead and reduced the weight on this unit. Aluminum inherently weighs more than plastic, but pound for pound, ounce for ounce, gram for gram, aluminum is a stronger material. So if you have 1 gram of aluminum versus 1 gram of plastic, for the most part, that's going to be much stronger. So not only were they able to basically make these parts a little bit thinner and take some additional machining holes in them and whatnot so that they could lose weight, they've gone ahead and they've gotten that specific preloaded MGN 7 in there, which is probably the #1 weight loss thing in here. So it's a little bit like Slim Fast for your tap. Yeah, so pretty cool. Looks nice, right? Yeah, goody, goody, good. All right, let's go back to the camera view and let's take a look at the inside, because Mama always says what's on the inside that counts, right? So, let's see here. 2 screws on the top are actually holding, what are those holding? Those are holding a, looks like a magnet plate. Yeah, so we'll leave those on there right now. We're just gonna take these bottom 4 out, and they're in there pretty good. And you know what? I'm gonna put my spectacles on here so I can not only look smart, but see better. Looks like a little bit of thread locker on these screws from factory, which is good. So, And if you didn't know, thread locker, actually you can remove a screw and replace it and it still holds for a few times. You can't do it dozens or anything like that, but you can get away at 3 or 4 times. So there we go. All right, so that's that. 4 screws out there. And let's go ahead and see about lifting this off of the rail. Ooh, there we go. Okay. And I heard this guy right here slide out. So I'm gonna put this back in here and we'll talk a little bit how this is, again, different than the average tap. So we already know that we're using MGN7. Surprising or not, we know it's there already. We just talked about that. So let's talk a little bit more about some other changes here. We talked a little bit about how things have been machined out a little bit. This is super thin right here, not aluminum foil thin, but pretty thin. It's got some of that oil on there from shipping. We'll clean that off. And here's a major difference with this thing that almost makes you say it's not even a tap. Even though it's functioning the same as a tap. It's a completely different design. I kind of like the idea of it. So here is the secret sauce for this unit. It's open source, so it's not really secret sauce, but they're using a very strong neodymium magnet right here on the top. Okay, so this magnet right here is inside of a little cage. That cage is holding the magnet where it is. And then what they're basically doing is, because this portion of the unit is riding on this sled, this magnet is actually being utilized to use, it's connecting to the rail. So as opposed to a couple screw heads, they're using the top of this rail as their source of ferric metal, or ferrous metal I should say, to connect to that magnet, which is very smart. I mean, it requires no additional parts. It's going to be there no matter what. And it's got a lot more gravity to it, a lot more mass to it than any screw head is going to have. So you really get a good snap when it goes together. So kudos to them, and it's probably relatively helpful because the weight of this is overall lighter, so you don't have as much force to work with. But yeah, so first things first, I'm gonna get a paper towel here, and I'm just gonna spray it with some IPA. I like to keep it in a sprayer, and I'm just gonna clean this bottom part first. And I'm seriously considering purchasing a complete kit from these folks, or maybe even seeing if I can get one in for the Warren 2.4 rebuild. I did buy this part, full disclosure. I bought this, there's no disclosure actually, but I bought this from Fabrico. I did not get any discounts. I did not get any free shipping or anything like that. I paid for this out of pocket. I actually paid for expedited shipping on this because I wanted to get it in quick. As soon as I looked at it, I had a couple viewers that had asked about this. I have one particular person, Woody. How we doing out there, Woody? That has purchased this and hasn't installed it because he had the plastic parts to build this tap, and I knew nothing about it. So he decided not to put it on quite yet. He decided to get his printer working for it first and then doing this. But I'm taking the plunge here on behalf of Woody and others, I guess. So little exoskeleton here on this part. And here's the tricky part. They specifically have told us not to remove disassembling the unit here. We're not actually going to disassemble it, but what we're going to do is we're going to clean it, and we're going to use my method. My method to cleaning a rail is relatively safe, I feel, and lubing it, again, safe. I'm not going to remove it completely off of the rail. I'm going to simply pull it about halfways in one direction, okay? And I am going to spray a high amount of IPA in there. I'm going to work it back and forth a little bit. These bearings are being held in place with the spring tensioners that are in there, so I'm not overly concerned about the ball bearings falling out, but I do want to run them back and forth real quick like that. I see a little bit of crud down here. That's normal. Doesn't matter who makes the rail, unless it's already been worked by a third party. Fabrico is one of those third parties that do that, and been lubricated by that third party. You're going to find crud inside of rails. So just part of the manufacturing process. They make them, They don't prep them for install. So, and the reason for that is they don't know when it's going to be installed. They'd rather keep it protected for the end user than fill it with grease that might dry out. So it's not them being lazy or cheap. It's you know, a method to the madness. When it gets to a third party like Fabrico, something like that, they know it's relatively soon that it's going to be leaving. They're not going to have it for a year or two. So at that point, it's pretty safe to prep that unit. All right, so we got that side. I'm going to go ahead and spray it on the other side now. When I do that, I've done this before on other videos for other rails. I'm doing it with force, so I'm giving it a really tight spray with the spray bottle. It wastes quite a bit, but IPA, it's cheap. It's not really hard to come by, so that's what you wind up with. Okay, and the other thing is too, I use a relatively decent, I think this is 93%. You get away with 91, you can use 95 or something like that, but you don't want to use something like a 70% because there'll be too much water in there. It's going to take too long for it to dry, because part of this whole process is the fact that you need this rail to be dry before you go ahead and throw the grease in it. So in terms of grease, I'm working behind my face, huh? In terms of grease, you can use, you know, there's quite a few greases you can use. The Mobilux is probably the go-to for folks that are into the Vorons, but a lot of people use lithium grease. I personally, on smaller rails like this, wouldn't see a problem at all with using a lithium grease and developing a lisp at the same time. But you definitely don't want to use anything with like a moly grease or anything like that, because those particles will damage the rail. You don't want to use that in any of your rails. I wouldn't personally suggest using a spray type lithium grease, the type that's in the can. You know that there are a couple different companies that make them. Those usually kind of liquefied a little bit beyond what I think they should be, or what's normally used. Get a little bit of air real quick. Pardon the moment. But I want to make sure the thing's dry before we put grease in it. So. And I'm going to get the inside of it here. I'm not going to blow too hard now. You got to be careful when you work on the inside of these. You don't want to dislodge these ball bearings. If you drop your balls, you're going to be in trouble. All right. All right. Now this thing is relatively crunchy. It's not bad at all, actually. This is a high wind rail, so this is a very decent rail in carriage. But I'm going to let that sit for another second. Let's take a look a little bit more on this thing. So right here, this is still looks like a two-part. Yep, it's a two-part, much the same way as the original Voron. So you got a top portion that's screwed in to the other portion. The electronic portion here with the tap sensor, the little micro optical switch here is removable, which means it's replaceable. So if you had to get a replacement part for that, you could. The circuit board on it looks relatively simple. It is noted signal, ground, and voltage on the board, so you can see that if you don't know what your pinout is, even though it's in the manual. All in all, it's very nice. I don't see any issue with the machining on here. I dare say it looks cast. It looks perfect. It probably is cast. Nope. I think I can see some machining. Yep, there's machining here on the inside. I can see it right here on the inside, but it's no place anybody's ever going to see. So it's not cast, it is machined. That's good to know. All right, So I think we're good here. We're relatively dry, and I'm going to be applying some Mobilex grease to this. Again, you could use the lithium. And what I'm gonna do is I'm gonna slide this rail about halfway off in the first direction. And I'm gonna try to apply the grease on here directly to the bearings. If I can get my, oh, there we go. Just gonna apply it directly in the inside here on one side, and then on the opposite side. And I can be a little bit liberal with it. Most of it's gonna fall right out, and that's to be expected. It's not a problem. You have wipers in there that are meant to keep things clean, and they're also going to wipe out that grease too. So it is what it is. You just want to get them lubricated the best you can. So I'm gonna go ahead and work that back and forth a little bit. I'm gonna wipe off some of this excess that we have right now. I can already feel that it's made its way in there and it's working pretty well. I don't feel any, call it crunch. I don't know if it's the right word, but we'll call it crunch. Now you do have little ports right here to put grease in, and you can jam grease in those. You know, those work okay if you're re-greasing and you don't want to take things apart, but I really don't believe anything is better than actually just getting in there and actually applying grease to the actual balls themselves directly. So I ran that through one. Let's go ahead and put another portion of grease in there. I'm just going to go on both sides again. Let it work through. Wipe off the excess. And then we'll do the other side again too. I know it's kind of hard to see in there, but here we go. Just gonna work that back and forth a little bit. All right, and clean up my mess. If you're playing with grease, it makes a mess. Nothing I can say or do about it. It's gonna happen no matter what. So let's go over here. So basically what we've done, just to give you a little bit more of a close-up, is we've opened this up like so. We've gone ahead and applied grease to the inside of the rail. We're not pulling the rail completely off because we want the rail to hold these metal braces that are holding the balls in. Those are kind of our safety insurance in terms of keeping those balls where they need to be. So doing one side like that, pulling it out about 2/3 of the way so we can get to about 2/3 of the unit, putting the grease in, folding it back the other way, and then getting the last third through here using this passageway through here and the very end over there. And then once you combine them both, you get 100%. Go ahead and do that, work it back and forth. And then once you get it back and forth, go ahead and do it a second time. And I can tell there's grease in there now because I'm having grease actually on my rail itself, and I never applied grease to the rail, so that means it's getting around everything. So that's pretty dang decent. All right, well, we have our new Chaoticlab CNC Tap. So at this point, basically, let's take a look what else is in the box. We have our interconnecting wiring here. I'll switch back to our other camera real quick. Interconnecting wiring right here, and like I said, it did have to put our own connector on here. I replaced it with a JST, originally it being XH, a little bit big for what we needed. Here it is, that's one I removed. So right there, repinned it. We got a pinout that's available in documentation, but again, the pinout is also on the board. I know what my pinout is on my printer, so that's not an issue. We got a little baggie here of screws for mounting, and then we have nothing fancy here really in the packaging, but it gets the job done. The mounting screws for the unit. Yeah. So let's see if we can put this thing back together now. So that is normally the front. This is going to sit like this. I hope. Yep, like that. And do I have this upside down? I think I do. Yep, it's upside down. It only works one way, so you get that going for you. So put this in like that. Yep. So let me see here. Gotta line up these screws somehow. Let's see, this should go on like this, right? That magnet is really powerful. It's always the little things. So yeah, this should be able to slide. How's this going here? Logic tells me I want to put it this way, but oh, I see. Okay. So this top section right here with the indent cut out of it or bent out of it is going to go up by the optical switch. So it's going to actually go around this top section here. Again, this is a lot different than a regular tap. You have the 4 mounting screw holes right here to put screws in when it comes time to actually mount this on the printer, which we'll do in a video here as soon as I get some additional figures from my tap, because my plan long term on this is to basically compare this to the original tap in terms of not only the functionality, how well this works compared to that, but I also want to check it in terms of how accurate it is to the original tap. So I need to get a lot more data off of my original tap first. So I'm gonna put these screws in. I will say one thing here. Nope, I guess they lined up. Putting that first screw in, kind of pulled it all together. And I am going to go crisscross on this. So first screw up there, second screw down here. Just make sure we get everything straight. Since I know I'm going to be mounting this sometime soon, I'm gonna go ahead and not tweak these all the way down as hard as I possibly can, but less of an issue here with installing these screws or any screws in this metal versus the plastic version, since the parts are relatively thin and could easily break. Not an issue with this. And there we go, there we go, there we go. Put these parts back in the box. I'm not using them right now, like I said. And we don't need that. There we go. Awesome. Yeah. So, seems pretty good. I don't need these glasses on now. Seems pretty good. Seems pretty nice. A lot more rigid than the original tap, that's for sure. Comes apart pretty easy. There's nothing too spectacular complicated about it. It is a lot different than the original tap. The rail on there, the Highwind, the 7 MGN, is very, very tight. Very nice. So we're gonna get this on the printer once I get some more data off my original tap, basically to see how accurate it is comparatively, see if there's actually a marked improvement on my probe calibration, my probe accuracy test. And once I have that information, we'll basically be able to, actually the video for that's gonna be basically me already having my information, my old tap, putting this new one on, and then running the probe accuracy test on this and accuracy test, and then comparing the two. So hopefully you guys stick around for that next video. We got more Clipper videos coming up soon. I have a live stream coming up if you're watching this this week that I'm actually putting this video out. It's gonna be Saturday. That'll also be up on the channel. You might get a notification. YouTube's picky about that stuff these days. I'm going to see maybe if I can get a complete kit from Chaoticlab to do my rebuild in the fall for my other Voron. If not, we'll do a normal rebuild. Who knows? But all in all, seems pretty nice, and I'll see you next time.